Right. So welcome back to lecture 8. And as you can see from the title, we'll be spending some more time with Simscape Electrical. So far, we have used blocks from Simscape Electrical. Those blocks were electromechanical motors, DC and stepper motors, and their drivers. We have used them before, but today we'll be looking at some electronic components within the Simscape Electrical library. And you may have used software like Proteus or other spice-based software to model electronics circuits and predict their behavior for given inputs before. In terms of just predicting the behavior, Simscape Electrical doesn't provide any added benefits, but for the task which come after the basic simulation, Simscape does really provide some additional functionality. So there's you might have some doubts as to why we are using Simscape Electrical in the same place where other software can also be used. My opinion is that the whole model based systems design, development, and implementation cycle does not end at simulation. And while other softwares, Proteus mainly, will offer some assistance with regards to designing the PCBs, there's more to model based design than that. And Simscape and the MathWorks suite environment really helps you with those tasks which come after the simulation, and and it will help you in the development and deployment phase. Well, in today's lecture, I'll be taking a look at a filter circuit. Mainly, I'll be looking at an extremely simple first order low pass circuit. First, we'll look at how to predict the behavior of such a circuit using mathematics only. Then afterwards, we'll use Simscape Electrical as I have promised over here in the lecture topic. And finally, I'll demonstrate how Simscape will be used for the tasks which come after the simulation phase. Now, with regards to resources, of course, you have to stick with the online documentation or the building documentation. There's no alternative for that when you're learning methods. And I have added two articles. One's actually a calculator to figure out what the passive circuit elements need to be based on what type of filter you're going to use. And the other is an article which you can use to brush up on your memory of low pass filters and filters in general. I'll have a datasheet for a 741 op amp, which is kind of the most commonly used version from Texas Instruments. And finally, I have added a YouTube link to a video which discusses the implementation of a low pass filter, however, as a digital filter within an Arduino board instead of using the circuits. Instead of using circuit elements such as resistors and capacitors and building a physical circuit, they have implemented it as a C code or Arduino code. Now, towards the end of the lecture, I will show you how you can use MathWorks Suite to develop a digital filter and can use the results of those developments and what you'll learn in this video to develop advanced filters and advanced digital filters and implement them on Arduino, which might come in handy if you're going to rely on some noisy sensor readings for your final year projects and any projects which come afterwards. Okay, moving on, I have added slides number 3 and 4 just for this lecture to become lecture material to be comprehensive. Slide 3 basically discusses what type of blocks are available in the Simscape library. This slide won't be any use to you, but you'll have to go over to your documentation and browse through the lists of blocks. And with regards to the rules of Simscape specific to Simscape Electrical, we have discussed them in lecture 5 or 6. I can't remember the exact number. But since we have already used Simscape Electrical when implementing motors and drivers and when interfacing motors with Simscape Multibody, we discussed these rules in detail. And for those of you who have kept up with the lectures and done the activities at home, I think these rules will now, perhaps in most cases, will be ingrained in your memory. That you putting in added effort to memorize or cram them into your brain. If you do the activities, then you won't need to go over the slides anymore. I have structured the activities in a step-by-step manner so that uh, without referring much to the slides, you will gradually get these fundamental rules built up into your memory just by doing the activities. Right. Well, that being said, let's move on. Now, as I described in the intro to this lecture, we'll be starting out by developing a simple mathematical model for this extremely simple filter, which is a first order low pass filter, in order for us to predict the behavior. Now, without the use of any without the help of any software. Now, once again, why do we bother with mathematics when we have tools which we can use to build circuits or systems as we see in real life and obtain or predict the behavior? Why we really bother with mathematics is that these mathematics are what happens behind the curtains when you develop a Simscape or Simlink model, and having some intricate or at least basic knowledge with the math would help you later on someday when you develop yourself to a level that you exhaust all the ready-made options available in Simlink and Simscape, and you have to build custom blocks on your own. Then this math would come in handy. Or not the basic math I'm doing today, but it would kind of act as a stepping stone towards all that, right? So just some info which isn't really necessary, but however, uh, I'll start out by discussing what a filter is. Now, I expect you to know what a filter is, since you are in your fourth year, and as my corresponding students, you must have studied filters in some other module earlier on, and your batchmates confirmed that this was the case. They had then that you were aware of low pass filters and filters in general. But just to recap, and in order for me to create a good flow within the lecture, I'll discuss what an ideal filter is. So let's consider the filter circuit as a black box where you have an input and an output and something goes on inside. In an ideal filter circuit, if you